So whether you've tried this or not, it really doesn't matter. Here in the main method, I'm going to reuse the main class that we've been working on throughout the course. And we've already got started in the previous chapter. We've loaded in this initial RDD, which is the input data for the Docker course. So that's our big data. That will be partitioned and split across multiple nodes in a cluster. I'll remove these lines at the bottom though, because that was for something else. This initial data is actually very noisy. It's worth having a little peek at the data. So a common thing that I will do is I will do a take on that RDD. That's the method I mentioned in the reference manual. That's just going to take the first however many we specify. So let's go for 50. Now, it might surprise you, but because you're doing a take and you're always taking a small number, Spark realizes that you've now really switched into small data. So there's no point making this into an RDD. You'll see the return type of this method is a regular Java list of strings. So I'll call this results and we'll loop around them and print them out. Lots of ways you can do this. It's standard Java, but since we're functional, I'm going to use the for each method that's present in Java collections, and I'm going to use the same technique as before. I'm going to use the method reference system.out : print line. So let's have a little look at our initial RDD. Okay, so yes, a lot of this initial RDD is not relevant. All of these timestamps and this sequential number, and in fact these blank lines, are of no relevance to us at all. So how do we get rid of this redundant data? Well, there's lots of different ways of doing it, but a really easy way would just be to run a map against this RDD. And for every line in this RDD, it's just a Java string. We can use the standard Java string routines to replace anything that's not a letter with a blank. So we'd be stripping out these square brackets, for instance, and that would just leave us with the regular word instructor. And for these lines here, in fact, it's going to strip out everything, so we'll just be left with a blank line. So this is almost regular Java. We would take the initial RDD, we'll run a map against it, and for each sentence, I'm going to be explicit here and remind myself this is a full sentence. We could call on that sentence, standard Java here, I could call the replace all method. Now that takes a regular expression, and wherever it finds a match for that regular expression, we can make a replacement. So we need a regular expression in here. So this is quite hard. I didn't give you any clues on how to do this. But it's just in square brackets, the caret symbol, and then A-Z or Z, lowercase, and then A-Z or Z, uppercase. And that's basically saying anything that is not either in the range of A to Z lowercase or A to Z uppercase, we're going to replace with a blank. So that's going to give us a new RDD. Now, as on the warm-up chapters, I'm going to take the approach of creating a new variable for every single transformation that we make on the RDD. And you might prefer that, but then at the end of this exercise, I'll compact it all down into a much smaller block of code. So we're going to have a Java RDD, and this is going to now be letters only RDD. The problem with using this approach is thinking of a good name for this RDD. And I'll need to remember that I'm now going to do a take on the letters only RDD. So I've just copied across to there. So always good when you're building up these jobs to do it step by step and then have a look at the format of what you've ended up with and make sure you're getting roughly the right things. Let's see what that looks like. Well, that's definitely a fail. As you can see, it's compacted every sentence into single words. In other words, it's stripped out all of the spaces as well. And that's because my regex is faulty. So this is saying everything that is not a character must be stripped out. So I've gone too far. I've stripped out the spaces as well. I can fix that quite easily, but it won't be very readable. If we just in here add in a space, then that will work, I think. Let me just verify if that works. Yeah, that's looking a lot better now. We've got our sentences preserved, but that's not very good really. In fact, in a regex, a \s represents a space. Well, you'll get a compile error in Java because a backslash on its own is not a valid character. You'll need double backslash, so that's to escape the backslash, and that represents a space, and I think that's going to be a lot easier. Well, a regex is never easy to read, but at least it should be a bit more obvious that we've included spaces in there. Let's try that. Superb. So there we have our individual sentences. Now, something else that we could do at the same time is we've got some words which have capital letters on them, such as Docker and Java and so on. Now, it would be worth probably, just to make the word count easier, to make everything be lowercase. And then we won't have the situation where we have Java with a capital J and Java with a lowercase j being treated as two separate words. And we can actually do that in this mapping. There's no need for a separate RDD mapping. After we've called replace all, we could then simply call dot to lowercase on that. I've just gone off the side of the screen there, which will just make it a part of that Java operation. So no real spark in there. I guess that just illustrates that you don't need a transformation on every single thing you're doing. Just to check that worked, yeah, we've got Docker with a lowercase d now. The next obvious thing, I suppose, is to get rid of these blank lines, which are just getting in the way really at the moment. And there are lots of different ways of doing this, and oftentimes it's just one way is no better than the other way. I would recommend, and we'll talk about this in the chapter on performance, I would recommend that if you have multiple ways of doing things, then think about how it might affect performance and do some benchmarking and see what works the best. But sort of the obvious thing to do here would be to run a filter on this and to filter any line that is blank, or to filter out any line that is blank. So how could we do that? Well, we're obviously going to end up with another Java RDD of strings, and let's call it removed blank lines. So we'll be taking our letters only RDD, and we're going to be doing a filter. So remember, we're given a sentence, and then we perform some logic, and if the logic is true, then that sentence will be added to the new RDD. So what we're really looking for is if the sentence isn't blank. So it might be something like if the sentence.length is greater than 0. That might work. I have a feeling it won't work though, and maybe you can think about why. Let's try it though. I just need to remember to make this take be pointing to the removed blank lines. Let's see what happens. Aha, well, definitely a difference. Some of the lines have gone, but some blank lines are still there. You can probably guess what's happening here. If I highlight my pointer here and do a little bit of a swipe, you can see actually these lines are not blank. There are some spaces, possibly even things like tabs and various unprintable characters have been left behind from our previous transforms. So it's not enough just to say if the line's length is greater than 0. Simple fix for this though, we're in standard Java here. We can take our sentence, and before we do the length, I'm sure many of you know this, there's a method on a string called trim, and that will remove any trailing or leading white space. Let's have a look at its Java doc. Leading and trailing white space. So the nice thing about this is it will remove more than spaces. It removes unprintable characters, and there's more information there on what it does, but that's definitely going to be a good way of cleaning up our data. So let's try that. And good, we're definitely on the right lines now. I think it's time at this point to get this data into the format of words. Well, you know how to do this. We did this earlier. Because we're going to do a map, and the map is going to split each line into its constituent words. We know there's going to be one or more words for each line. Of course, we're going to need our flat map to do that. So I won't over elaborate this because I think what we're doing here is pretty much identical to what we did before. So this is going to be just words, and we'll take the remove blank lines RDD and we'll run a flat map on it. So given a sentence, oh, it's that awful thing where we've got to, on the sentence, we've got to call split. So we're going to be splitting on a space, but then we've got to convert it into a list using arrays.asList. And then that's not good enough for Spark. It doesn't know what a collection is, apparently. We have to call .iterator, and that will make Spark happy. So if that was too quick for you, then we covered that in the previous chapter on flat maps, so just go back and review that. So let's do a take on just words and see if we've got the right kind of data. Looking pretty good to me. Well, of course, most of these words are boring. So definitely words like and to and this are boring. Interestingly, I know this sounds a little bit off, but to us at Virtual Pair Programmers, the word Java's boring, for this exercise at least. And it's boring because the word Java will appear in every single course we've done, or at least most of them. So we'll have determined that, and it will be part of our boringwords.txt file. So how do we filter out the boring words? Well, I've given you the answer there. We'll use filter. So this is going to be another Java RDD of string. Just the interesting words. So this is going to be our just words RDD. We're going to run a filter, and given any word, we just want to keep where that word is not boring. And I mentioned in the introduction that we have this class called util, which has a helper method in there called isNotBoring. Thank you very much. Pass in the word, and that will return true or false. So that should leave us with just the interesting words. Let's see if it does. Okay, well, this does look more interesting than before. At first glance, a lot of the words are not what you would recognize as regular words. So yeah, it's looking good. This Docker, Stacks, microservice, Netflix, Tame, Java jar. Yeah, and we've got some odd words like this one here, which is just a result of the subtitling. They probably had spring.profiles.active, etc. Now that probably won't be a problem because that won't get a high word count and will just fall off the bottom of the chart anyway. I do realise looking at this that I do have a blank line there, unfortunately, so I have let some bad data get through somehow. And that's often the case. Whatever you do, you end up with things that aren't quite as you expect. And I'm not going to think too deeply about this, but I suspect what's happening, after I've filtered out all of the blank lines, what's going to be happening, I'm guessing, is that a few of the sentences might well have things like double spaces. So what's happening on this line here is we're ending up with some spaces coming out as words. We really didn't want that to happen. So you can kind of squint at this for a bit and just try different things. But I reckon I guess what I could do, the lazy way out, would be to do another transformation here where we remove any blank words. It seems like quite hard work, that, given that we've already done some filtering of blanks. And actually I think it would make more sense if we did these two operations the other way around. So in other words, once we've got our sentences all in lowercase, we'll then split into words. Now some of those words will just be spaces. then we can do a filter taking out any words where when we've trimmed them, their length is 0. So it just means reordering all of this, which is a bit of a pain. So I'm going to leave that for now. You never know, it might be that those blanks don't end up in the final top 10 words or whatever. So we'll keep an eye out for that until later.